Hi, everybody. We're doing S.14, which is complete a table and graph a linear function. So I'm really looking forward to this one. I like filling in tables and showing you how they connect with what you see on the graph. So I haven't previewed this one, so it gets to be a surprise for me. S.14, let's take a look at what we're doing. One of the things you want to keep in mind is that you can always choose whatever x value you want, and it just happens that they chose a pretty easy one here. So let's see. They said that x plus 3, and we want to find f of x. Now, the way that we write this, if I were to write this out, it would look like this: f of 3, and this one would be f of 4. And this one would be f of 5. That's how we say that. And what we do is we substitute instead of x and add the 3. And instead of the x and add the 3, and so on. So this is the part that's going to be missing. 3 plus 3, of course, is 6. And this one gives us 7. And this one gives us 8, and so on. And you can probably see the pattern from there. So it looks like we're looking at, I'm going to close this out for a second. So I've got 6, oh, come on, 7, 8, 9, of course, and 10. Be careful, make sure that these are actually one after the other, because otherwise the pattern won't hold. Obviously, we can add 3 in our head. Now we're supposed to graph the points. Looks like we're looking at 3, 6 to start with. So 3, 6 is right there, and the next one is here. Oh, I guess we're only supposed to just graph the 2 points. Let's see. Oh yeah, it only lets you put 2 points on there. But there's the points anyway. And this is, of course, 3x plus 3. And where's our submit button? I don't see it. Looks like we're done, maybe. Oh, wait. Oh, dang. Where was it? 3, 6. Oh, there. So 3, 6, and that one, and so on. Okay, let's see what happens if I put next. So there we go, submit. Okay, so we fill in the table and then we'd graph it. So 2x plus 5. If you substitute 0 in there, I want to point something out. We love 0 for the following reason. And we're going to call this f of 0. This is called the y-intercept. And it's so nice because no matter what number is on the coefficient of x, it doesn't matter. You're always going to get this number over here. So f of 0 is equal to 0 plus 5, or just 5. So this one is 5. The next one is going to be 2 more than that, because I'm going to be multiplying 2 times 1 plus 5, which is 7. And then I'm going to multiply 2 times 2, which is 4, plus 5, which is 9. Notice that my y values went up 2 every time the x values went up 1. So we're at 0, 5 to start. And we have a slope of 2. There it is. And in this one, this is called a direct variation problem, or we can say that x is proportional to y. Lots of ways of talking about it. Of course, we're going to go through 0, 0. And we're just multiplying by 3, which gives us 3 and 6 and 9. And we can put in our points. This is 0, 0 with a slope of 3. Goes through 0, 0 with a slope of 3. And we're done. And this one is a negative slope. That means it's going to go down 2 every time our x's go up 1. This is the rate of change. So basically, every single time, just a note, this is going to go down 2. This one is also going to go down 2. This one is also going to go down 2, because these are going up 1, and our slope is negative 2. We're starting at 8, but f of 1 is going to give us -2 times 1 plus 8, which is just 6. It's -2 plus 8, which is 6. So I'm just going to put 6, 4, 2, and of course 0. You can substitute it in and see that's true. By the way, that point right there at the end is not called a y-intercept. That's an x-intercept. And it's really easy to get those two backwards. So I'm going to go ahead and graph the ones. Let's graph the x-intercept. Why not? The x-intercept occurs at 4, 0. Now, the problem with graphing this is that it's a -2 slope, and I can't very well go down. But I want to mention something. If I were interested in graphing -2 over 1 as the slope, I could also graph +2 over -1, which is read like this. I go up 2 and back 1. And you can see I'm going through 0, 8, I'm going through 1, 6, and 2, 4, and 3, 2, which were some of the points that we got up above. This one we're just adding 2. So we add 2. Be careful, these are skipping 2 each time. So 1 plus 2 is 3. 3 plus 2 is 5. 5 plus 2 is 7. And it has a slope of 1 and goes through 1, 3, but it also goes through 0, 2. It's up to you how you want to do it. I'm going to go ahead and put the 1, 3. And it looks like we have a slope of 1, doesn't it? And hopefully you can see that we have a slope of 1x plus 2. And 5, 7 is on our graph. Let's take a look. 5, 7 is on our graph, isn't it? You only have to graph 2 points in order to find a line. And this one, we're going to multiply everything by -3. So this is going to be +3. This one is going to be -3. And this one is going to be -9. So we've got 3 points. I'm going to go ahead and write them out here. -1, 3, and 3, -9. I'm going to graph these 2 points. It just happens to be -3x. Now, anytime you ever have an equation like this, y equals -3x, it's going to go through the origin 0 times anything is 0. So it goes to 0, 0, and we have a slope of -3. That's down 3 and over 1. Take a look and see if it goes through -1, 3. There's -1, 3, and +3, -9, which is right there, isn't it? So it's definitely the right. This one, we're going to multiply by 6 and then subtract 8. 0 times 6 is 0, so we're just going to get a -8 here. And then we're going to multiply by 6 and subtract 8, so we're going to get -2. And then we're going to get 4. That's 12 minus 8 is 4. And 3 times 6 is 18. And when you take away the 8, you get the 10. If you need to write them out, go ahead. I'm going to graph the 0, -8, and then count my slope. So I'm going to choose 0, -8 as my first point. That's my y-intercept. And I have a slope of 6. That goes up 1, 2, 3, 4, 5, 6, and over 1. And you can see that I'm at 1, -2, aren't I? Let's see if, was that one of our points on there? Let me see. 1, -2, there it is. And 2, 4. Let's graph 2, 4 real quick there. There it is. And so on. If you ever want to check your graph, you can always, look at your points and put them in there. Now this is -2x plus 12. I'm going to put it there so that I can graph it on the side. Now I want to put in some points here. If I put 1 times -2 plus 12 is 10. And 3 times -2 is -6. When I add 12, I get 6. Let me write that for you here. F of 3 is equal to -2 times x plus 12. And so I'm substituting the 3 in. That's -6 plus 12, which is 6. Just so you can see it. The way we write that point is 3, 6. And 7, can you do it in your head and get the -2? And 8 gives you your -4, doesn't it? So there's our points. Here's our graph. Here's what we're graphing. This guy right here. And I just want to mention that an easy point is 0, 12, which is not on my graph. So I had to choose something that is on my graph. So I'm going to choose the 3. 3, 6 was one of the points. So I'm going to choose 3, 6, which is one of my points. And I have a slope of down 2 over 1. And there's another point that I think was on my graph. I don't remember if I graphed 5, 2 or not. Anyway, that is that equation that you see over there. Oh, I spaced. I want to submit. There we go. And we're going to put this one in. Oh, very interesting. This is called a constant function. And it's not very interesting. Well, it's not very interesting because nothing happens. This is like going to the dollar store. Everything costs $1. No matter what UPC code you put in, the cash register is going to ring up $1. This is a $4 store. So everything costs $4. 4, 4, 4, 4. Not very interesting. Y, or f of x, is always 4, no matter what we do. So if we graph this guy, if you start graphing some of the points, now some people are just going to automatically try to memorize that it's either going to be a vertical line or a horizontal line, and they're almost always going to get this backwards. Because even though this says y equals 4, it seems like it should be a vertical line, but it's not. This is a horizontal line. One way to see why that's true is that this is the same thing as this. These are both the same. And a slope of 0, of course, is flat. That's one way of looking at it. But another way of looking at it is that if y is always 4, I want you to look at what happens to the graph when y is always 4. No matter what point I'm picking here, y is always 4, isn't it? You see what I mean? I think one of our points was -7, 4. Oh, -7, 4. Anyway, there's lots of points there. You'll notice that this graph is y equals 4. Do you see why people get them backwards? You see, x equals 4 is a vertical line, and it seems backwards to them. The x-axis is where y equals 0, and that may help. This is the x-axis, and that's the reason that people miss this so often. So there it is. I know, more information than you wanted. Just tell me how to do it. So 0 goes in here, and we get 7 out. Oh, darn it, I didn't mean to put the dots. Let me get rid of it. Oh, dang it. There we go. Okay, so I'll get rid of that. I'm going to substitute in my head and get the 7 because we love 0. 0 times anything is 0. And when we add 7, we get 7. Now, 3 times -2 is -6. And hopefully you can add the 7 in your head and get the 1. The next one is going to be -3, isn't it? And 7 times -2 plus 7 is going to be -7. And what about 8? Oh, 8 times -2 is -16. And when you add the 7, you get the -9. Now, one of the things you might have noticed is that each one of these went down 4, because these are going up by 2. Not obvious to a lot of people that the rate of change in this one, actually went down 6 in this one, didn't I? Dang it. There we go. I went, why isn't it? Oh, I see the problem. There we go. Dang it. There. I went, there. I was trying to erase. That was the problem. Okay. Notice I went down 6, but this one went up 3. And if I look at the change in y over the change in x, it is still -2. This one went down 4, but this one went up 2. So down 4 over 2 is -2 as well. Just something to keep in mind. Anyway, I know more information than you wanted. I'm going to write the equation so I can do it really quick. Y equals -2x plus 7. And I could choose any one of those 2 points, or I could just graph it from scratch, which is what I prefer to do. I'm going to graph it from 0, 7, which was one of the points in my graph, and I have a slope of -2, which is right there. Notice that my x-intercept is at 3, it looks like maybe 3.5. There we go, 3.5, 0 actually. And it looks good to me. And let's do another one. Oh, f of x is equal to -4. So this is, again, a constant function. It looks like we have a -4, a -4, and a -4. And hopefully you know this is a horizontal line right here, where y is always -4. It doesn't matter where I go. This one is a slope of 1. I'm going to go ahead and write it. Y equals 1x minus 14. And I'm just going to subtract 14 in my head. It's not that hard. It's -10. It's going to be -7. And it's going to be -6, isn't it? So it's not that hard to fill in your table. And then you're going to graph it. Now the problem is I don't have a -14 to graph, but I could graph 8, -6, couldn't I? So 8, -6 is right there. And we have a slope of 1. Well, a slope of 1, up 1 over 1 looks like that. I could also go down 1 and back 1. Doesn't really matter. There's another point that works and so on. Let's see if I, nope, can't see any more of it. All right, that's just, you see, I can't go to my intercept. See, my intercept's at 0, -14, but it doesn't show on this graph. Oh, f of x equals 9. Looks like we get another horizontal line. For a vertical line, it's not a function, and we're graphing functions. So that's why we're not getting any vertical lines. Vertical lines are never functions, because x could be anything. In this case, we've got it y equals 9, or f of x equals 9. It's up here, where f of x always equals 9. In this one, oh, we get a fraction, finally. At least we have even numbers to put into it. A lot of people are going to really get killed here because they're going to have to do a lot of work. They're going to grab their calculator. You don't need a calculator for this. Let me show you why. F of -10 is equal to -3 over 2 times x minus 11. And I'm going to substitute in the -10. The 2 is going to cancel with the -10 to give me -5. And I'm going to get 15 minus 11, which is 4. So my first y value is 4. Now what I want to show you is that I can actually count this, count the slope, just like I can on the graph. Now let me show you what I mean. Watch what I'm going to do. You see my slope is the -3 over 2, isn't it? Well, do you see that these are going up by 2 each time? That's +2. And that one is +2. And that one is +2. And so on. This one is +2 as well. I want to be careful I don't submit by accident. Let me put in a number here. Let me get rid of this for a second. So what I want to do is I want to go down 3, because my slope is down 3 every time x goes up 2 or over 2. So this is 1. I went down 3. If I go down 3 more, I'm going to be at -2. If I go down 3 more, I'm going to be at -5. If I go down 3 more, I'm going to be at -8. negative 8. Now, if these x's had not gone up 2 every time, then I would have had a lot harder time, and I would have had to substitute it in and yada, yada, yada. But as it is, I've got lots of points to choose from, and I'm going to rewrite my equation one more time. Let's write it. Y equals negative 3 halves x minus 11. And there is a problem here. I can't put the negative 11 on my graph, can I? See what I mean? See, the negative 11 doesn't show up on my graph. But what I can do is I can pick any one of these points. Look, if I pick this point, for example, you know what? Which one I want to pick? I want to pick that, maybe this. I was thinking I'll pick this first point that I started with. Let's go ahead and pick that first point, negative 10 over 4. And I just want to show you something. And I'm going to show you physically what we did with the numbers here. So I'm going to use negative 10, 4. So one of my solutions is negative 10, 4. And I'm going to graph it. Negative 10, 4 is right there. And I'm going to count my slope. I'm going to go down 3 and over 2. Down 3 and over 2. Notice where I am. Hopefully everybody recognizes negative 8, 1. Now I'm going to go down 3 and over 2. And I'm going to be at negative 6, negative 2. And if I go down 3 and over 2, I'm going to be at the negative 4, negative 5. And if I go down 3 and over 2, I'm going to be at the negative 2, negative 8. And there's all the points that we found. And I did it physically on the graph. So there you have it. Now I can submit. Sorry, I know, too much information. All right, just x plus 7. We're just going to add 7. I'm going to get the negative 2. I'm going to add 7 and get the 4. I'm going to add 7 and get the 9. And we just have y equals x plus 7. It's the same as f of x. F of x and y are interchangeable. Since I start at 0, 7, it's right there. And I can count up by 1s or down back by 1s, whichever. Oh, there we go. Looks like we have a few more, and I'm getting kind of tired. Let's see. We got 6x minus 45. Oh, interesting. I like this. So take a look at your graph and look at your y-intercept. A lot of people want to automatically just grab a y-intercept, and it ain't going to work in this case. Look, if f of x equals 6x minus 45, I'd like for it to appear on this graph here. And if I put in 0, I'm going to get negative 45, which is not on that graph at all. So think about some numbers that might work. Can you think of one that's going to be on this graph for sure? Well, I want a number close to 45, don't I? So let's try 7. 7 times 6 is 42, minus 45 is negative 3. So I have a point right now. Now I want another one that's close to 45. What about 8? 8 times 6 is 48, and if I subtract 45, I get 3. How about if we graph those 2 points? Those 2 points are on our graph. 7, negative 3, that's going to be right there. And 8, 3 is going to be right there. Now, does that look like it has a slope of positive 6? Does it look like it's going up 6 and only 1 over? And sure enough, that's what it looks like. If I were to go all the way down to negative 45, it would actually cross the y-axis there. So there you have it. X minus 6. Well, they just want me to graph it. So let's graph it. Y equals x minus 6. So I'm going to get rid of that. I'm going to start at 0, negative 6, and then I'm going to count a slope of 1. Any one of these points should work. If I put in 6 for x, I should get 0 for y, and I do. F of x equals 2. I hope you all know what it looks like. It's going to be where y is always 2. Nice, easy one. And this one, oh, this one's more interesting. I'm going to go through 0, 7. I like the 0, 7. And now I'm going to count my slope. I'm going to go down 7 over 2. Down 7 over 2 is going to put me right there. And that has a slope of negative 7 over 2. One of the things I did was I always put my negative in the numerator. And it looks like we're on our last one. This one is going to go through 0, negative 4. And we're going to have a slope of negative 1/3. That is down 1 and over 3. That is a negative 1/3 slope. We could have counted up 1 and back 3. It would have worked out. Anyway, there it is. And we're all done. Did some tables. And I hope you guys are going to get these yourself. So I will see you back. Bye.